2D array problems can be hard. What makes them harder is not having basic patterns mastered before trying to solve more complex challenges. Here are 5 basic 2D array patterns that you should be able to write blindfolded, and which I will write blindfolded later in the video. Here's a 2D array pattern that you should know blindfolded, looking at the neighbors of a given location in a 2D array. By neighbors, what I mean is up, down, left, and right. Now this seems simple, and it is, but I've seen people eat up 20 minutes trying to figure this out and making sure they don't have any errors, and that's bad because usually this is part of a bigger question on an exam or in an interview. If you're spending 20 minutes figuring out something so simple, you're really not on track for getting the bigger question correct in a timely fashion. So let's write this quickly, and let's write it blindfolded. First things first, I'm going to be looking at the item at ARR bracket R bracket C, sort of the current relevant item, many times, so I'm just going to make a variable to hold that. Okay, and so the key thing to keep in mind here is that you're going to be looking at up, down, left, and right, but you need to check that those indexes are inside the 2D array before you try and look at that item in the array. If you don't, you're going to crash. So let's just go through those one at a time, checking each neighbor location. And if I didn't find any neighbor that was inbounds and lower, that means I don't have a lower neighbor, so in that case, after I've checked them all, I will return false. Okay, javac star dot java. And I never remember what the file name is called, but fortunately there's only one file in here. See if I got it. Gotta put my glasses on. Ah! Okay, nice, got it, yes. You should be able to flatten a 2D array using for loops blindfolded. By flatten, what I mean is that we take a 2D array that sort of stands tall, like this, and turn it into a 1D array by lining up the rows end to end. Let me make sure my mouth is in the right spot to talk into this microphone. I am going to make an int array called result equals new. And how many items should result have? It's going to have items equal to the total size of the input array, and the total size of that is going to be number of rows times number of columns. I'll just say arr.length times arr bracket 0 dot length. Okay, well, I'm wasting a lot of time if that one character was off. I'll have to refilm this, but hopefully that's fine. Int k equals 0. K is going to track where we are at inside of that result array as we're copying items over. Here is the start of our standard 2 for loops that we use to look through a 2D array. This is sort of the default starting point for looking at all the items in a 2D array in the standard common order. And if you can't get these 2 loops correct very easily, you need to do more studying, and you probably shouldn't be messing around with more serious 2D array problems. Result of k, not I, equals AR brackets I brackets j. Then I'll say k plus plus. You could actually increment k within the square brackets on the line above. That would work. Plus plus k would not work, and if you want to know what the difference between those is, I do have another video on that. Close my brackets, return result, and hopefully that was fine. WQ, write quit, and javac star.java. Hopefully that didn't really say anything. If it did, I'm refilming. And now I've got the moment of truth, flatten. Okay, what's it say? I think I passed. It looks like there's nothing there. Did I pass? Yes, nice. Running a linear algorithm on the column of a 2D array is so common and so simple that you should be able to do it blindfolded. I've got a 2D array here with the lighter colors representing higher numbers, and I want to run a linear algorithm on this column. For example, I might want to know the average of this column. So I sum down the column, and then I divide by the number of items in the column. Easy enough, let's go ahead and write it blindfolded. So double total equals 0.0. Many students, both high school and college students, write this wrong. And what they do is they associate nested for loops with 2D questions, and they jump right into using a nested for loop. We don't need a nested loop here. It's a linear algorithm. It just goes in a line straight down one column. As we go down a column, the column does not change. It's the row that changes. So ARR brackets I, which will change as we loop, bracket C, which will not change because that's what this question asks for. It's asking to average down the C column. Then we just return total divided by the number of items in that column. Now, how many items are in any given column? It's equal to the number of rows there are, which is just ARR.length. Here's the thing, this is by far the easiest pattern in this video, and I've already recorded it several times because at first, I was clicked in the wrong window, so nothing showed up. I had another typo when I compiled it. I found out one of the tests had a typo in it, so I'm really hoping this will work because it's not that hard. Okay, hopefully that didn't say anything. Column average. Oh, please it worked. It looks like it worked. Nice. Finally finished that one. Yes. We often have a 2D array, and we want to know some specific data point about each column in the 2D array. For example, here's a 2D array, and I want to know the maximum element in each column. I'll store those maximum entries in a 1D array and return that. So the general pattern here is that we're using a linear function to reduce each column to a point, and we're putting those points for the whole thing into a 1D array. Now, how difficult is this, really? Not that hard, but it's so common and so useful that you should be able to write it blindfolded. Let's go. Okay, there's my mic. That's a little high, but I guess that's what I'm going with. So double brackets, we'll call it maxes equals new. Now here the idea is that for a given column I will walk down the rows, and that will be the inner loop. The outer loop will just walk across each column from left to right. So this is a column major traversal for int j equals 0. And then what I need to do here is I need to make a value to hold the max for a given column. So then I'm going to make my inner for loop. This goes over the rows. It's the standard for loop. If max is bigger than the current item, it stays the max. If the current item is bigger, that becomes the max. The one-line way to use this, the one-line way to do this is math.max. Max equals, then I need to set maxes, brackets j, equal to the max. Return maxes. We will see if that worked. I really hope it did. And Java star.java. Okay, I think that worked. Let me put my glasses on. Ooh, oh, thank God. I don't know what those memory addresses are, but yes, wow. Matrix multiplication is so vital to so many systems, including LLMs and other types of AI, that it's worth knowing so well that you can write it blindfolded. We're going to multiply a matrix A by a matrix B, and that results in a matrix C, and we write it like this: A times B equals C. Each element of C gets computed with this equation. Okay, what is that? What does that mean? Let's unpack it. We can make this clear by looking at the top left item in C and thinking about how this equation would apply to that top left item. This is row 0, column 0, the first row in the first column. That's what those little zeros next to the C mean. And I'll clear out some space here to show you the math. To compute the entry in the first row and first column of C, I look at the first row of A and the first column of B. And I'll multiply the first item of the row in A with the first item in the first column of B. And then I add the second item of the row in A times the second item in the first column of B. And then I add the third item in the first row of A times the third item in the first column of B. and so on, walking across the row of A and down the column of B until I finish with that row and that column. I'll get a 32 here, and that fills in one item in the result matrix C. Then I'll move on to the second item in C. I'll keep an extra variable K here to track where I am as I walk across the row A and down the column of B. Actually, the code for this is really not bad if you understand how the sizes of A, B, and C relate to each other, and you're also quite comfortable with for loops. You can also write this blindfolded. Let's go do that. So our first step here is going to be to make our results array, which we're calling C. And how big does that need to be? If it's M by N for A and N by P for B, the result has size M by P. M by P. So it's the number of rows in the first part and the number of columns in the B, in the right side. So B bracket 0 dot length will be number of columns. After that, it's really just a bunch of for loops. It's not so complicated. It's going to be the standard 2 for loops that tell us what position we're at inside of C, what position inside of C we're currently filling in. And then it's going to be just another loop for that K variable that I mentioned while I was showing the animations. For int K equals 0. K is less than, Okay, now that needs to be that middle value. Let's do the number of rows in B. As I said, those should be the same. If they're not the same, this isn't going to work right. Okay, this part's easy. Look. C, I, J plus equals, then it's going to be A, I, K times B, K, J. Okay, that's it. Then we close, 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 return C, and we should be done. Probably not, though. I probably made a typo somewhere. WQ, javac, star.java, java matmult. Okay, we'll see what it says. No way. I mean, I told you it wasn't that hard, right? It's just like, can you type for loops really well is what it boils down to. I cannot. Okay, that was honestly like first try. I didn't have to some of these I have refilmed, but not that one apparently. Wow. Nice. My name is John and I'm a computer science teacher. I hope the blindfold caught your attention and you learned something here. I offer private tutoring for high school computer science courses and for college level data structures and algorithms. If you're interested in private tutoring with me, check my link in the description, and thank you for watching.